Alright, we are live. March the 7th, 7 de marzo. Let's see. What do we have here? Nothing that I am interested in. I don't know. Anyway. Alright, you ready? Let's take a look. Today's a Sunday. I expect it's going to be not an easy one. That's my expectation. Design Hashmap. Oh, man. Design a hash. So what? It does say do not use the built-in Hashmap library. All right, so we're gonna have to design our own scheme for hashing. All right, let's read about it. Design Hashmap without using any built-in hash table libraries. Okay. To be specific, your design should include these features. Put. Insert a key. If the value already exists, update the value. Get returns the value, yeah. Well, -1 if this map contains no mapping. Remove the mapping for the value if the map contains mapping for the value, right? So basically it's a design a hash map. Put, get, put, update, get, remove, get. Key values will be just integers. Number operations, whatever. Do not use the built-in. So thinking back on the algorithm class that I've taken, we actually dealt with Hashmap extensively, and I think I even wrote a custom Hashmap in Java, but I actually forgot how we implement the hashing. The hashing function. Now the hash function, the given value is so huge, so it's impossible to do a hashing function just with a bucket idea, because it's too big, right? So we're not going to do it that way. So we'll have to handle collisions. Now there are many ways to handle it, right? We can use linked lists, which we probably won't implement the linked list. We'll probably just do another list. It's going to be like a list of lists. That'll be our internal structure for the hash map. So the main list will be, I don't know, a certain length. You need to decide. I mean, there are rules like the collision rate and all that good stuff, but I forgot. And if we just want to pass this, we probably don't want to worry about it. But if it's an interview question, we might get asked, like the collision rate and how you manage it, right? There are many ways to do the hashing. The simplest way is we do a mod, right? So we set up our internal array, the main array, our key array, be, let's say, I don't know how big. So it's given us 100. So 1 million. So 0 to 1 million, right? So our internal, let's say, let's do 10,000. Maybe too big. I don't know. Maybe too big. Maybe 10,000 is too big. I mean, on average, if we have 1 million and our internal arrays, let's say 1,000, and on average, each key will have size of 1,000. Will we consider this to be a good enough rate? Like, because we have collision, and each time we have collision, we have to iterate through every single one inside the 1,000. Inside the 1,000 linked lists. Well, not linked lists, but it's going to be an array. And will we be happy when we handle this? We probably will not, right? Let me think. 1,000 by 1,000. So it's going to be like a 1,000 by 1,000 matrix. Iterate through 1,000 items. That should be fine. We might get away from that, or or we do 10,000, right? So our list will be 10,000 in size, the key list will be 10,000 in size, and then the rest will be only 100 on average. So that's fine. Now we need to handle collisions. And the thing is, the collision, will it happen more often? If we have 10,000, right? So the collision will happen, on average for each key, we'll have about 100 collisions. I guess we're fine with it. I mean, this way shall work. What I'm thinking about, like, there are many ways to compute the hash map, right? So you have direct mod, or you can do like pass it through like a linear function, and then if it's occupied, it keep doing it. So that's like another way of handling. It's kind of like each time you're passing the actual value through a function, and then if it's occupied, you will do it again and do it again until we find a value, a key that's not occupied. Right? That's another way of implementing it. But I think I'll just go for the easiest implementation. Right? Not sure about the performance. Definitely not sure about the performance. And in that case, so yeah, so it's going to just be a list of lists, right? A list of lists. And we probably have to initialize it with a list of lists. I don't know how long, if maybe we'll run into, let's say, a memory overflow. I don't know. Let's give it a shot. And we're just kind of thinking out of our own brain. It might work, it might not work. We need to really take a hard look at it. And let's code it up first. I mean, it will be fairly easy to code up using that, and I'm sure that this will be considered as one of the solutions. Although there might be better ones. So we're gonna have to initialize. It's gonna be a list of lists, right? So we're gonna say self dot hmap. Can we just call it map? It's gonna be, let's say, a list for in range. How long do we want it to be? Let's say 10,000, right? Let's just say 10,000, and then we probably also should say the size equals 10,000, and we just going to use self.size here. So now when we put, we're gonna find the key, right? So the key is going to be, we're gonna pass a key to it. So we probably shouldn't put the key here, and we just say index, right? Index equals key mod self.size, right? And then we go inside self.map to the size, and then we have to iterate through that thing, and then just to see if we encounter the value. Like if we did not encounter any value, then so it'll be like this. I'm going to say for val in, actually not val, for k in self.map. So we're going to say index, right? If k is equal to, to key, right? If k is equal to key, we're going to break. But we don't know which one it is, so we have to have also an I here. So we need to update it. So I'm going to say enumerate this thing, right? If they're equal, we break out. Else, which means the key is not inside this this list. So if it's not, then we are going to say we're going to say self.map index. We're just gonna dot append, right? We're gonna append. Append what? We're gonna append the value. We're gonna append the value, right? So if it is equal, we actually don't break it. We just immediately say self.map index and I equals value. And then we break. And that's it. That's our put. Now our get will just be index, same thing, index equals key, mod self.size. So after we do that, we are going to do exactly the same thing. We probably can just copy and paste it. So we're going to iterate through everything. And we say if I is equal, then we're going to return k. And then we say else, we're going to return -1. Right? Remove. Oh, remove is going to be interesting. So we don't want to remove because remove is going to cost a lot of time. So we're gonna make it a little bit smarter by because I'm just thinking, but you won't know, right? You won't know. You have to iterate until the end. But how about, what if we have some value that is, you know, like if I remove on the head, right? If I remove the value on the remove is on the head, how do we know? And we have to iterate until the end, but we have to iterate until the end. And if we say remove, and we directly remove it, and it will cause on to remove. And I suppose it's not going to be efficient. Let's just try it. This is the dumbest idea, right? The dumbest idea. I have another idea, but I guess it's fine. So remove key. What if when we call remove, it's not in? If this map contains. So if it does not, then we don't do anything, I guess. So same thing, we have to iterate through. Oh, it feels like this can be simplified into another function, so everyone wants to call it. So if k equals key, yeah, it will be easier. I just set it to a value, right? So we know all the key and values will be in this range. So if I just set it to a negative value, then I don't have to remove it. Right, so if it's equal, then I just say self.map index I equals -1. Right, I just set it to this, and we don't have to really do any movement, and then we're done. Now, if we do this, then the put will have to change. Right, so if we put a value, then we first need to know if this value exists inside. If it does not exist, then we need to put it in, say, one of the indices that is currently empty. So what we can do is we can set up another one. Right, so we have an index and we have a empty, gonna be just a list. And then as we go through it, we say if k is smaller than 0, right, then empty.append I, so we include the index of the empty ones, right? And if we are good, then that's fine. If we're not good, then we need to find one in the empty. So we're going to say if empty, which means we have empty values. Then we just say self.map. We just pick index, pick any one on the empty. So we just pick the first one, and we just set it to value. And else, only if the empty, we don't have anything empty, then we append a new one. Right? So that's that. Now when we get it, we go through and find that's actually fine, and get should be fine. So this we kind of avoid removing stuff. So let's give this a shot. Not sure. Let's see. Run with this example. We actually got a wrong answer here, which is supposed to return 1, but we return -1. Which one is that? So Hashmap is no, put, get. As a first get 1, we got it. Second get 3, got it. First put and get. We got -1, but it should be 1 because we put 2, 1. Why did we not get 2, 1? So it's something wrong with the put. With put, we go through let me think. We put 1, we put 2, and we get 1, we get it. And we put 2 again. Why is the 1 not coming out? Why I return -1? Right? And then remove. Then I get. Very interesting. Hold on. Which one is it? Hashmap put, get, put, get, remove 2. So it's get 2. We'll go through, so the index shall be 2. So we're going to 2, right? And then we iterate through. The first one shall be the key. And I shall be doing it so when we say get, we create index, enumerate it, and then we find if k is the same as the key, we're going to return. Well, first of all, I don't think we should return k. But first of all, what are we storing there? I think I got it confused. Hold on. Start from the beginning. I think I got it confused. We're storing the value, right? Yeah, we're storing the value. How do we know that? So we need to store not just the value, but a key value pair. I just realized we need to store a key value pair. Otherwise, how do you know as you iterate through that this is your value? It is going to be a key value pair. Oh my god, I just got it completely wrong. So, man, this is going to be a key value pair. So we're going to be a key value pair here. And I'm going to say if, then it could be, well, key value, we're going to set it to -1, which is fine. Actually, I think we're going to take it out, put it in as a list, another list, so we can actually modify it. So we get it out as a key value pair, and then if the key is smaller than 0, we know that this is not real. And then if the key is equal to key, then what we're gonna do is I1 equals value. Alright, so that's the key value and become new value. But if empty, is going to empty 0. We are going to say, actually this one, well, you're going to switch it into key value, so it's the key value pair. If not, we are going to append key value pair, and when we get it, it's the same thing, so we have to say it, call it, it's going to be a key value pair, and then if key is equal, then we're going to return value, right? If no key is matching, then we return -1. If we want to remove, we're going to set it to -1, -1. Now I feel like even more complicated, but I guess this is how it's going to be. Oh, it's wrong again. What? What? At the end, maybe I think the remove is not doing it right. If we remove, right, so we say, as it's going to be -1, -1, and when we get, it should not equal to key. Why would you return? All right, I think we need to. Holy moly, we need to. So issue with get. Let's just call it every time we call get. It's kind of, giving us an idea what self.map look like. We need to debug this. Right? Oh my dear Lord. Yeah, this is going to be huge. So we did not actually. So 0, 1, 2, right? And we call remove, as we call get. We have two get and remove. Oh, we didn't really. And we call get again. So wait, how many times do we call get? And why do we only get 2 output? I have no clue. Let's only print the first 5. All right, let's only print the first 5 and see. Yeah, there we go. There we go. So we call get. First time we call get after we push, and then we get again. That's good. Now we put again, then we call get. We change it, and then we call remove, and it does not remove. So the remove has issue. Why is that? Well, we say remove 2, so 2 coming in, index will be 2. So when enumerate on 2, which is this one. Oh, I think I know, because we forgot to make it key value pair. There we go. That is the fix. That shall make it work. Yeah, I forgot to change it. And we're going to remove the print, and this one shall pass. There you go. Let's have to take a look. I mean, the only thing I worry about is the runtime, but apparently I think the runtime is okay. And we are like medium. That's fine. But I don't quite like a lot of the implementation, so I'm going to try. Can we, get it even better? It look at this. We are repeating the same thing. We're repeating the same thing. So we can create a function that returns to us. But then for this one, we also need to know where the empties are. Well, the empties can be given by this, right? Every time we do this, and we have the empty ones. We can record the empties. So are you saying we need another one another list of lists to record the empty value positions. But if we do that, how do we update that empty value position? We update it here. We update it here. Every time we use the empty, then we are going to update to remove it. Are we going to remove it? Are you going to remove it? It's going to be a stack. We just pop it. Pop the bottom, and then we always append, and we pop. I think that might make it better. So we can write a function. Then we can say after we pass in the key, it will return to us the index. Right? The index will return to us. It will return to us the reference. Because when we return the reference, right? We return the reference of that. How should I put it? Because all we want to know is the reference to. We don't have to know the reference, so we just want to return the index. And so the index after the mock and the actual index inside this thing, right? That's the only two things we want to know. And when we return, for this, we have, we find it, or we did not find it. If we did not find it, we're just going to return -1. That's fine. And if we find it, we are going to return the actual index. So we'll have two indices, right? Two indices. And we're also going to maintain a map for the empty. So the empty is going to be the same. So we're maintaining two things. Let's see, what's the memory usage? Pretty bad. So we want to try to do this. Yeah, we can try. So I'm just trying to see. Let me hook it up to a new one. So we probably should write some comments on this one. And I would just say this is a linked list. It's a list of lists implementation of Hashmap. Very basic, no special, very basic. Collision is handled by extending the internal list. Removal is handled by resetting the value, resetting the target key value pair to -1. Yeah, that's basically what we do. And we run at 236. I mean, amortized to 01, and this one we get a 59% ranking. I mean, the change I want to make is just to make the code look, slightly nicer. So I want to have another thing. So I have a map. I want to have an empty as well. So it's going to be the same thing, but we're going to use a stack here. And we're going to push a find, not the, just one. We're going to call it a find. What do we call it? Find, say find target, right? So we're going to just pass this key. We just need a key. I'm going to return you, let's say, a list of int, right? So what we're going to do, actually, I'm going to return a tuple, which I feel will be a better option. So we're going to do basically this entire thing. No, not this entire thing. This entire thing, right? So we're going to say, we're going to first decode the index and then look for it. And if we find it, we're going to return the index, and I. So index and I is what we're going to return. Index and I. And actually, we don't use this v. So we're going to comment it out. So we're going to return this I. And if we don't find anything, so we're just going to return index going to return -1, so both are going to return -1. So now, how do we use it? We want to put something, so first we're going to say index I equals self.find target key, right? So we find the index, and if the index is, index will never be -1. So we should still return index. Index will always return, it's just this I, right? So now we're going to say if I is larger than 0, larger than equal to 0, so that means we have found, now we just put it in, which means self.map index I1 equals value. Done. Else, if it's not, then we need to check for empty, right? For empty. So we're going to say if self.empty index, then we're going to say self.map index self.empty index.pop equals key value, right? So we just switch it to this. Else, which means there's nothing empty, then we're going to call self.map, and then we're done. So it kind of save a few lines. Well, get will be first calling this, and we're going to return. I'm going to say return self.map index I index I1 if I is larger or equal to 0, else into -1. Remove will be the same, so we call it first, and we're going to say if I is larger or equal to 0, because remove we have to really find it, right? If it's larger than or equal to 0, then we set self.map index I equals -1, right? We set it to a, just a round value, and this I think will work as well because I did not change the logic. I just kind of make it look a little bit nicer. So there's no change whatsoever to the logic. I just make it shorter, like the get and remove is a little bit shorter. I'm going to run the code just to see if this one will work as well. I think it does. Submit it. And we accept this one, and I don't expect the result to be any different. Yeah, it's about the same. And the memory usage is bigger, that's for sure, because we are using two list of lists. I'm going to just say it's the same. This is the same implementation as above, but with fewer lines of code and more memory usage, because we use an additional list of lists to handle empty positions, empty spaces. All right, so these are my solutions, and let's see what are the smart people. What are their solutions? Oh, and this one doesn't have. Okay, design hash map. This is a easy question. I mean, if you want to design a really nice one, I think it's not an easy question. But I kind of just forgot how it's actually working. Design hash map. It is an easy question, right? It's an easy question. Just want to see how other people are handling it. Oh, it's called chain. It's called chain solution. Okay. Java. Are they doing list linked list? Put. Okay, so list node. 10,000. Do the same. 10,000. And new list. List node. Previous is fine. They have a find function. Oh man. Is this a linked list? I think that is a list node is a linked list. List node int and list. Okay, I don't understand. Let's try the Java one. This takes too much time to try to figure out. This is a linked list for chaining. Why are you using linked list for chaining? I don't understand. Oh, array solutions. It's called chaining. Oh, 90% when it's set to 1000. I don't know why using array not acceptable. I don't understand. It's the same thing. It's just you have to implement a linked list. I mean, a linked list when you implement it, it's the same thing. It's exactly the same thing. I mean, you might have to write a little bit more code for linked list. Yeah. So if it's you initialize to none, that's true. And then if it's none, you need to set up a new list node. Yeah. And then if not, you just have to traverse the linked list. Update it if you find it. If you do not find it, I mean, okay, so I see the point of using linked list, because if you're using linked list, then removal becomes easy. You just going through it, you find it, and just remove it, right? The removal becomes easy, but you need two. You need a current and pre. Yeah, you need two. Just do that. Actually, from a space standpoint, linked list is better because it's the most efficient in the space usage. Which, in another sense, is actually making... You know what? I think linked list is actually a better solution. Yeah, linked list is better. That is good point. Good point. Upvote this. Good point. Yeah, let's do this again. Let's do it in linked list. Yeah, let's do it. Let's do it again. Yeah. So let's say I've already made some very good points. What hit me? I used array instead of linked list, but the disadvantage. But the disadvantage, I use array initially without much thought. But come to think of it, linked list provides at least two advantages. First, it provides an easy way to handle removal. In array, removal is expensive. In my case, I try to set up flags in the array when a key is removed, but that not only makes the code more complicated, but it also leads to the second point. Can I make two advantages? First, let's just say first, it provides an easy way to handle removal. In array, remove is expensive. In my case, I try to set up flags in the array when a key is removed, so as not to invoke removal of an array element. But that not only makes, however, not to invoke removal. However, this not only makes the code more complicated, but also leads to waste of space, which is the second advantage of linked list. Efficient space usage. Therefore, linked list shall be the only option. Alright, let's do it with linked list. Yeah, I think it's inevitable. We will have to do it with linked list. I kind of forgot about the benefits linked lists have. So we just need to create a new class, which is called list node, and we do initiate self. What do we need first? We need key value, right? Key value. That's it. Key value. Yeah, I just need key value. I'm going to say self.key equals key. Self.value equals value. And self.next equals none. Right? That's it. That's our list node. Do we have to, what? Yeah, I think that's pretty good. Now, initialize, we have a size. He says 1000 is better, let's just try 1000. And the map is going to be none. None times self.size. Right, so we have one on nones, and then we probably don't need, I don't know, we might still want something like this, find target, right? So we still want to find target. So we still need to identify the key, right? And then after we identify, we can always add at the beginning. So that, now it starts coming back to me. We don't have to add at the end. We can always add at the beginning, right? Every time we add at the beginning, well, we still have to, shall only add the beginning. Right? We still have to traverse, right? Traverse. So we're gonna return not a tuple, but we're gonna return a list node or none. What's MyPy for that? I think it's option, right? I think we have a optional. Yeah, I think it's optional. Yeah, it's going to be optional. So we are going to return in optional, option, opti, optional, right? Optional. God, optional list node. So it could either be list node or could be none. So we find this, right? And then we need to say, what do we say? Current equals self.map index, right? And say while current, if current dot key equals key, then we return current. If not, current equals current next until we exit, and we then return current. And we actually don't need to return here, we just break and then we return it here. So now we're going to return, right? So when we put, we will first find out, actually we need index as well. Oh, what are we returning now? Now it's just going down. Now it is a tuple. Now it's a tuple. It's a tuple of integer and optional list node. Yep. So here we're going to say index and the node equals this, right? And then we're going to say if node, right? And then we just say node dot value equals value. That's it. Else, then we say, so we haven't found it. So we say self.map index equals a new list node, and we're going to say key equals key, value equals value. So that is put. Now get, we call the same function to begin with, and we're going to say if node, right, we're going to return node dot value if node else -1. And removal, same thing. It has to be if. So we traverse already. We have to traverse it twice. We kind of don't want to traverse it twice, do we? I mean, we already have it, but I mean, what if when we traverse, we always have two, right? And then we just don't use it in any of the other ones. That's a thought, right? That's a thought. So what we're going to do is we have a current, and we have a previous and a current, right? And while current, yeah, let's have two. So we have pre and current, and we're gonna pay attention to current. So while current, if current key is equal to the key, then we break. If not, we're gonna set pre equals current and current equals current next. Now we're gonna return this, and when we unpack it, we don't need the pre, so we just like this, right? We don't need the pre, but here we do need the pre, right? So we have this, and we're gonna say if node actually it shall be, because if we search through and we don't find it, then the node will be none and the pre will be, so whenever node is none, that means we didn't find anything. So if node, which means we will find something, and now we just need to delete. And delete is very simple. It's just going to be pre.next equals node.next. Done. Then we removed it. Wow, it's also easier to implement. Well, we need to see if this one pass. Let's go submission. I'm surprised, I've never done this before. I think this shall be a better solution. Let's see if we got it correct. Typo, just typo. Pending. Wrong answer. Where did we get wrong? The last one. Our output is 1, but actually it's a -1. Why is that? Why is that? The last one is after remove. It always happens with remove. I think the remove still has issues. So pre and current, and then say if node, then pre equals current equals current.next, next round come and break. That's fine. And then if it's not, pre move forward, current move forward, and then when we exit, it's going to be none. Oh, I think it's because we only have 1, so we actually need to also think about the edge case, right? I mean, after we set and then we want to remove 2, so we have a node at self.map2, right? We have a node there. Then what do we do with this node? We need to remove this node, right? We need to remove this node. And how do we remove? We use this find target function, which gives us while current, right? So current and current dot key equals key. That's true. So we break it and we return current and pre they should both point into the same node. And then when we remove it, and the node is correct, right? Node is correct. So what do? We say pre, which is node itself, dot next equals node dot next. So we did not remove it. We did not remove it. Yeah, when we only have 1 node, we did not remove it. To solve this problem, I think the only way we can do, which is a nicer way, is we're gonna have pre is going to be a dummy node. All right, gonna be a list node. Key value is going to be key is going to be -1, value going to be -1, and actually I want to set next as well. So next is going to be a list node. It's going to be none. Actually, we can actually set it here. There's a default value. This is our default value, and then this is going to be next. Oh, probably have an underscore just so that it won't complain. Next is a keyword, right? So we can just set this with next equal to next underscore equal to current, right? So we set a dummy node. Oh shoot, there we go. So a dummy node. And then we can do, then pre equals pre.next, right? I just call it pre. Why you call it prev? I don't understand. Pre equals pre.next, current equals current.next. So they're both moving forward. Right? That's fine. This is fine. And then when we return, right? Return, we're gonna call it current and pre as well. So if current, which means it exists, and then we're gonna say pre.next equals current.next, right? But I'm not, how do you need to set this node to, even with, how do you delete the head of a node? I have current here, and we say pre.next, and we're gonna return. How do we handle this situation that it's a head? How do we handle the situation that we're at a head? Well, we'll just turn current into, cannot turn current into none. So if we do this, what we have is the dummy, right? The dummy.next becomes none. But man, how am I get stuck here? This is a linked list. This is my favorite. I mean, I have a dummy node, right? Just for traversing purpose. And then if I delete a node, if it's at the end, no issue, right? Yeah, if it's at the end, there's no issue. But as to the front, we do have an issue because the head is, man, let's think. So, I know. So after we do this, we're going to check the pre, right? We're going to check the pre. So if the pre does not move, that means we know the current. Yeah, so we can say if pre.value, the key, is smaller than 0, which or like if it's like a flag, right? So if we know that, then we know the current head has to be set to none, which means we can call self.map index equals none, like this. So this is a check to see if the head of the linked list is removed. Yeah. Otherwise, I don't really see how we can handle the situation of the head being removed. I don't know. I think this one shall work. Change a little bit, and this one looks nicer as well. I'm going nicer compared to the other solution that I had. Run code. This one shall work. What is this? Oh, I didn't change this. I thought I don't have to. Man, I do have to change the class node. Right, try it again. Linked list. There we go, we pass. And then we submit this. Shall be much smaller in terms of memory usage. Oh, we got a wrong answer here. We got a wrong answer with this. What the hell? And I don't even know where the error happens. Oh my dear Lord. Hello? Show me the error. Wait, what is the error? I honestly don't. Wow, this is hard to debug. Oh, is it this one? 6. No, we have. Can we see the detail? Oh my god. I have to run a diff on this. Oh my god, I can't believe this. Output. This is our output, and it's wrong. Is that like any edge cases we didn't take care of? Find diff. Oh my lord. Are you saying all of these are different? What? Where are the difference? One removal, one addition. Are you saying that it's like completely different? What the hell? Oh, I see it. I see it. No. A7045. And I got -1. So something gets pushed in, but I did not recognize it. This is meaningless. Hold on, why would this be the case? Oh man, this is frustrating. Is it because like I mean we handled it, right? We say a list node. The dummy node is the only one with negative values. The dummy node is the only one with negative values. So when our pre is stuck, oh, I think it is not none. It's pre.next. I know where the issue is. It's pre.next. It's still, yeah, it's pre.next. Come on, that's the head. That's the new head. This one's alright. Oh my god, it's still not correct. Are we stuck in the same one? I think we're stuck in the same one. Well, for one, this definitely is pre.next. Because when pre.key is smaller than 0, right? Because all the keys are larger than 0. So if the key is smaller than 0, that means pre doesn't move, right? That means pre doesn't move. Because here we can see pre does not move when pre does not move when the current is matching at the front. So that our head is, yeah. Oh, I think this is actually also wrong. When you put value, and if I don't find it, this, we need to specify its next. Next shall equal self.map index. Yeah, and then this is wrong too. Man. Come on, man. Try it. I'm sacrificing 3. There we go. Now we're right. Very basic, adding new nodes and remove old nodes. I don't understand why I struggle so much to get this right. I don't understand. This is just so simple. I think, man, it's just probably one of my off days. I can't believe it. I forgot that we need to set up a new next node on this. And I kept thinking, and this is actually wrong initially. I set it to none, which is wrong because we are removing the head. You cannot set it to wrong. Man, this is embarrassing. Very embarrassing. I'm deeply, deeply embarrassed for this question. Should have done it like a piece of cake, and then just drag it on and on. All right. Anyway, I don't think there's more to say. Finding a diff is definitely not going to work, but we'll regroup and we try to do better tomorrow. So that will be it for this. Yeah. I'll see you guys tomorrow. Have a good day. Adios.